Hello and welcome to Dare to Know, interviews with quality and reliability thought leaders. I'm Tim Rogers, and today I'm pleased to welcome John Ayers. John Ayers is a consultant and the author of Project Risk Management, How to Avoid Failure, which is part of the CERM Academy Series on enterprise risk management. John earned a BS in mechanical engineering and an MS in engineering management from Northeastern University. He has extensive experience working in both commercial and defense companies. He's managed numerous large, high-tech development programs valued at more than $100 million. John has held a number of positions over his career, including Director of Programs, Director of Operations, and Engineering Manager. He has experience with design, manufacturing, test, integration, contracts, project management, risk management, and quality control. He has extensive domestic and international subcontract management experience. John is a certified Six Sigma specialist, a member of PMI, and he's certified to level 2 in earned value management. John Ayers, welcome and thanks for joining us.
Well, thanks for having me on, Tim.
John, in your book, Project Risk Management, How to Avoid Failure, you talk about risk-based problem solving and risk-based decision-making. Would you describe risk-based problem solving? How is it different from other kinds of problem solving?
Sure. Thanks for the question, Tim. Risk-based thinking, which is RBT, is a critical element of ISO 9001, the 2015 version. RBT has always been part of the ISO 9001. Now, the 2015 version has explicit requirements that are integrated into the entire quality management system. RBT, as defined and described by ISO, is difficult to operationalize or audit. For example, how does a person operationalize or audit risk-based thinking? What evidence or artifacts or data is the auditor going to find based on someone else's thinking? That sounds pretty difficult to do.
Sure.
Greg Hutchins wrote a book titled Enterprise Risk Management, in which he defines risk-based problem solving and risk-based decision-making as new terms in response to RBT. Those you can get your hands around and work with. He owns the trademark for these new terms. So risk-based problem solving is identifying and assessing the risk. And then risk-based decision-making is how to handle and mitigate the risk. So the second part of your question is how is it different from other types of problem solving? Well, other types of problem solving are based on the past, whereas risk-based problem solving is based on future events. And let me use Boeing 737 MAX as an example, which experienced tragically 2 crashes weeks apart. So what caused the crash? A preliminary report from investigators indicates that it crashed because of faulty sensor, erroneously reported that the airplane was stalling. The false report triggered an automatic system known as the Maneuvering Characteristics Augmentation System, or MCAS. This system tried to point the aircraft's nose down, which is the typical way if you're stalling to gain speed, so it could gain enough speed to fly safely. When the pilot tried to control the airplane, he couldn't, and it crashed. So FAA typically finds the cause of the problem after the fact, when it is too late.
Sure.
Lessons learned from the investigation, though, are usually incorporated to new planes, so that will help prevent future crashes. Now, with the risk-based problem solving, there would have been a risk assessment that hopefully would have identified the risks with the MCAS system. then the risks would have been assessed and mitigation plans put in place. So if they did a good job with the risk assessment, chances are the planes would not have crashed.
John, this sounds a little bit like what we used to call defect prevention. It's basically prevention activities or designing systems to avoid a problem.
Absolutely. That's exactly what it does. But, this is the difference between the two. One is after the fact, and the other
Yeah,
one is in advance of the fact.
that makes sense. John, our most of our audience are reliability and quality engineers. They've been trained to focus on the design of products, but your book suggests they need to think about project management and subcontractor management as well. Why are these areas also important?
Well, thanks for the question. The many projects I worked on included a fairly difficult reliability requirement because it was a Department of Defense rather, project. Now, I was taught that reliability is designed into a system.
Right.
And I learned that verifying a reliability requirement was done by analysis, but you have to validate it by test. Otherwise, you don't know if the analysis is accurate or not. So you need to consider the manufacturing and installation risks of the system. You also need to consider subcontractors' risks. This is when risk management comes into play to ensure system reliability requirements are validated during testing. In other words, you cannot have problems with manufacturing, installation, or subcontractors that prevent you from validating the reliability analysis because, as I just said, you don't know if the analysis is right or wrong. So let me give you an example.
Yeah.
Now, I was the lead for a red team review. The red team is an independent team that reviews, they aren't associated with the project. And it was of a preliminary design for a radome. And this was done at the request of our system division. They did not have the background in radomes to review it themselves, so they asked us to do it. Now, for those who aren't familiar with a radome, it is a fabric dome that covers an antenna or radar system to protect it from the environment. In this case, the radome had to survive a 200 mile per hour wind, which is a very extreme requirement.
Sure.
This was also a subcontract. Well, the PDR did not go well. The reliability analysis did not show the requirement was met. And it was based on using the best known fabric to date. So that meant that in order to meet the requirements, a new fabric invention would be needed to meet the requirement. So the red team, we failed the review, which meant they had to go back to the drawing board. And shortly thereafter, the red team was disbanded. Well, about a year and a half later, I heard that the radome was actually installed, but it ruptured during acceptance test.
Oh, good grief.
Yeah, the test was to load the radome to the 200 mile per hour wind loads. Now, the investigation of the failure revealed that the radome was over-tested. They put too much pressure in it that exceeded the 200 miles per hour. It was also not fabricated properly, and these are the two causes of the rupture. So the test never validated the reliability analysis. The cause of failure was due to the subcontractor mistakes made during the fabrication of the radome, and also by our testing engineers over-testing it. The subcontractor incorporated mistakes. For example, he had too many fabric folds up near the peak during the manufacturing process. Now, chances are, if they had done a good risk analysis of the manufacturing process and the test plan, the problems that caused failure may have been identified and mitigated, which meant the test would have validated the reliability analysis. So this is why you need to think about project management and subcontract management risk beyond just reliability.
John, you've mentioned several different types of project risks. Can you go into a little more detail? What are those different types, and how do they affect reliability?
Okay, sure. First off, there are basically two types of risks on a project. They are programmatic risks and technical risks. A project cannot meet schedule, hence the budget, without resolutions of issues that affect the schedule. Events that impact the schedule are programmatic risks. These types of risks determine the risk level of the project. So if you have a risky schedule, you have a risky project. If you have a low schedule risk, then it becomes a low level risk project from just a programmatic risk viewpoint. Now, these types of technical risks, I should say, issues can cause schedule and cost impact, but can be worked through. For example, applying more resources to the problem to solve the issue, or performing more tests to determine the problem and then fix it. So programmatic risks are the key ones that can really affect your project. Now, let me give you some examples. Programmatic risks first. Current IMS has little slack for schedule slips, so that's the risk. There are always uncertainties and assumptions when creating a schedule. To mitigate these threats, additional time is built into the schedule to mitigate them. It's called slack. If you have enough slack, then the probability of the schedule slip or delay is low. The second example, current subcontractor has no proven track record. How selecting an unknown subcontractor to provide critical components or services to your project is dangerous and risky because you have no experience with them. So it's much more prudent to go with subcontractors that are known to you, or at least they can show evidence of a successful track record. Now, let me give you a couple examples of technical risks. Weight requirement has little margin. Now, weight is a major concern on a lot of things like ships, space, rockets, airplanes. If there is insufficient weight margin in the design, then chances are the weight requirement will not be made, probably resulting in a costly redesign. So a mitigation plan in this case would be to add weight margin in your design. And then getting now to reliability, system reliability requirement is very challenging. Some military systems have a very high reliability requirement because the mission it is supporting is critical to the defense of the country. And analysis can be generated to show if the system meets the reliability requirements, and that's what they do. But if the numbers do not show it meets the requirements, there are several actions that can be taken to increase the reliability value that the model predicts. For example, you can add redundant subsystems such that if one fails, the other kicks in. And you can also eliminate single point failures. So those are some of the things you can do to get your analysis numbers up to the requirement. But as we said earlier, you still have to validate it by testing.
Sure. John, most of your work experience has been in the defense industry, but you say these risk-based techniques can also be applied to the IT and construction industries. Can you give some examples?
Sure. Let me start with the IT industry. The Obama Care rollout is a good example of an IT project that went terribly wrong.
I remember that.
Yeah, in spite of numerous contractors telling them, there's a lot of risks here involved when you're rolling it out. I mean, you should not ignore them. You should address them. But the government ignored them and defied virtually every basic IT and management rule you can think of. Here's some examples of that. The first one, 2 contractors initially took the lead building the system. Now, when you have 2 people in charge of something, it means you have nobody in charge.
That's right. Yeah.
And then another thing is beyond the maze of technical problems you'd expect, which is pretty usual, it was found that there's inadequate management oversight and coordination, and that prevented real-time decision-making and efficient responses. And you know that you have to have very good, solid, clear responses to questions to move the project along. And then CMS, representing administration, failed to follow up on how well the contractors performed, so they had no oversight. And then contractors are not given a coherent plan, poor plan. Instead, they jump from issue to issue, which also caused problems. So as a result, the cost went way up. For example, the sign-up system part of the plan went from $56 million up to $209 million. And the back room, they called it, for verifying applicants' information, jumped from $30 million to almost $85 million. So it was out of control, over budget, and behind schedule. But if a risk assessment was done, and I don't think it was ever done, it should have been done. And if the rollout, I should say the rollout would have been much more cost and schedule effective if they actually did a risk assessment. Now let me move to the construction industry. I was mentoring an aspiring project manager that recently started a new job with one of the large oil companies. She was assigned to a project for building a new refinery, which was approximately 50 miles from the sea shore. And included in that contract was also a new seaport where they could bring materials in, unload them, and then they'd drive them up to the refinery site. Now, one of the areas that we discussed was risk assessment. She told me one of the major risks was traffic on the existing road that ran from the Newport location to the new refinery location. The road happened to be a 2-lane highway. So the risk was if the road is used for normal traffic and construction traffic, then the congestion will cause schedule and budget problems for the project. And in my view, that's not even a risk, that's a for sure thing.
Sure, good point.
So I advised her to recommend to her boss that adding temporary and parallel construction vehicle roads would mitigate the risk. I explained to her that that was the approach the Big Dig took in Boston.
I remember that.
And it worked well. So she passed it on to a manager. And later on, I asked her what happened. And she said, they decided the best mitigation plan was to perform a study. So in other words, they ignored the risk. And in my view, this is one example why a lot of construction projects are over budget, behind schedule. But having said that, I think the Big Dig did a good job in addressing it.
Very good. John, this has been great. Thanks so much for being with us today.
Well, thank you for having us, Tim. And I enjoyed talking about project risk management.
That was John Ayers, consultant and author of Project Risk Management, How to Avoid Failure, which is part of the CERM Academy Series on enterprise risk management. This is Tim Rogers. Thanks for joining us.